Alright, here we have the notes for section 1, linear functions. So you've got your objectives there. Use increments to calculate slopes. Find a linear equation and sketch a graph of a line given specific information. Identify the relationships between parallel lines, perpendicular lines, and slopes. And solve two linear equations simultaneously. So here we have, there we go, increments and slopes. So an increment is just the change in any variable. So the example they have here is t from t1 to t2, x from x1 to x2, or y from y1 to y2. And it's denoted as follows. So this symbol is the Greek letter delta. It means change in. So change in t is t2 minus t1. Change in x is x2 minus x1. Change in y is y2 minus y1. So for example, find the increments delta x and delta y from the point 1 comma negative 3 to the point 4 comma 5. So to find delta x, that's the change in the x values. So it's x2, 4, minus x1, which is 1. So that is 3. You can repeat the process for the increment for y. So delta y is y2 minus y1. So 5 minus negative 3, so that's actually plus 3. So the increment is 8. Second one here, find the increments for these points. So once again, delta x is x2, which is 5, minus x1, which is also 5. So the increment for x is 0. The x value doesn't change. And for y, you have 1 minus 6, which is negative 5. All right, so here, diver descends below sea level to a depth, or from a depth of D120 to D225 meters. The pressure increases from 2.988 to 3.485 atmospheres. What are the increments in depth and pressure? So similar thing. So delta D, increment for depth, D2 minus D1, so it's 5. Increment for pressure is P2, 3.485, minus P1, which is 2.988. And that one I can't do in my head, so handy dandy calculator says 3.485 minus 2.988 is 0.497. Alright, so let's flip it over here. Alright, so linear functions. Linear function, the variable y is a linear function of x. That should be if the ratio of the increment y to the increment x is a constant. So delta y over delta x is constant. Now this is actually the same thing that shows up down here in the slope. So delta y delta x is actually the equation y2 minus y1, x2 minus x1 for the slope of a line. So as long as the ratio remains constant, you have a linear function. So for example 2, given a line through the point 2 comma through the slope of negative 2, find the y-coordinate of the point on this line that has an x-coordinate of 3.6. So they give us one point, and we have a second point is going to be 3.6 comma unknown y value. So slope is m, so in this case it's negative 2, is equal to y2, so there's our y value, minus y1, 3, over x2, 3.6 minus x1, 2. So this is negative 2 is equal to y minus 3 over 1.6. If you find the difference there. So this is dividing by 1.6. To try to move the 1.6 to the other side, you need to multiply. So negative 3.2 is equal to y minus 3. And then add the 3 across. So y is equal to negative 0.2. Alright, so example 3, the pressure on a driver is a linear function of the depth d. We know that the pressure at 20 meters is 2.988, and an increase of 5 meters in depth corresponds to an increase of 0.497 atmosphere. Find the pressure at 23 meters, 42 meters, and at 16 meters. So the pressures are acting like our y values. The depth is acting like our x values. So it's delta y, so for this equation, m is 0.497, change in our y value, pressures, divided by our change in depth, 5. So it says find the pressure at 23 meters, 42, and 16. So here, this actually is a coordinate 20, comma 2.988, so kind of like they gave us a point up here. And we can use that to find these ones are random x values to find their corresponding y values. So let's see if I can fit this in here without casting too many shadows. So the slope, 0.497 over 5. So for here, it's the pressure is our y value. So at sea level, so that's our, that's our y1. So y minus 2.988 over x2 is this number here, 23 minus 20. So this would be 0.497 over 5 is equal to y minus 2.988 over 3. So I'm going to do a couple steps at once here. I'm going to divide this 0.497 by 5 and then multiply it by the 3 to move it across. So 0.497 divided by 5 is 0.0994 times 3 is 0.2982, and then I need to add that number across, so plus 2.988. So the y value here is 3.2862. And you can repeat that process for all these different depths. So for the second one, 0.497 over 5 is equal to y minus 2.988 over, now our depth is 42, minus 20. So 0.497 over 5 is equal to y minus 2.988 over 22. So do the division, multiply by the 22, and add that value across. So 0.497 divided by 5 times 22 plus 0.29. Right. So for this one, the y value is 5.1748. And then for the last one, 0.497 over 5 is equal to y minus 2.988 over, where am I? 16 meters. 16 minus 20. So 0.497 divided by 5 times, that's 4. No, sorry, negative 4 times negative 4 plus 2.988. So for this one, y is 2.5944. And those are all your answers to that. Okay, so example 4 says using the information in example 3, find the linear equation that describes the pressure P as a linear function of depth D. So that's going to be pressure is equal to some slope times D plus some starting value. So pressure and depth are going to stay our unknowns. Our slope, we actually know it's this number right here. So 0.497 divided by 5. So that's 0.994. And then to find the B value, we actually have to work, we have to work that one out by using one of our pressure and depths. So I'm going to use these numbers here. So 2.988 is equal to 0. Oops, I missed a 0 there. 0.994D, which is 20, plus B. So on the right hand side here, 0.0994 times 20 is, so this is 2.988 equals 1.988 plus B. So if I subtract that across, you get 1 equals B. So my equation is P equals 0.0994 times the depth plus 1, which actually, whoops, off the bottom, makes sense because at sea level the pressure is 1 atmosphere, so if you have 0 depth, you're at 1 atmosphere. Let's flip it over here. Okay, so here we have a point slope equation. So this is the point slope equation. Sometimes you'll see it written like this because this is already solved for y. So in this equation, y1 and x1 are the coordinates for a point, and m is the slope of the line. So this y and that x will stay y and x. So example 5, find the point slope equation of the line with slope 5 that passes through the point 2, 3. So here's my equation, y minus y1 equals m, x minus x1, and I just fill in my values. So slope is 5, so there's my m, and the y value is 3, and the x value is 2. And that's actually as far as you have to go, since this has point slope form. Now, if it says slope-intercept, you'd have to simplify that down. So other linear equations, so you have slope-intercept form, which is mx plus b. That's what you would get if you distributed your 5 and added the 3 across. Then you'd end up in slope-intercept. You also have general form or standard form, which has ax plus by equals c, and both these values can't be 0. Is this second part there? Okay, so next up is parallel and perpendicular lines. So parallel lines have the same slope. It specifically says non-vertical here, just because vertical lines technically don't have a slope, so they can't be equal to each other. If they're perpendicular, m1 and m2, the two slopes, must equal -1. So what that's referred to as the negative reciprocal. So if your first slope is a over b, then the second slope will have the opposite sign and also be the reciprocal. So here, find the example for line 3, 5 parallel to the line here. So from this line, all I actually need is that slope. So I'm going to use point slope. So y minus the y value is equal to, since they're parallel, my new line that I'm doing will have the same slope as that line. So 2 and then x minus 3. So that's the equation of a line that's parallel to this one and goes through that point. So the second one here, line with x-intercept perpendicular to the line with that equation. So if the x-intercept's 6, that coordinate is actually 6, 0. That's where it crosses the x-axis, so the y value is 0. Now I need to rearrange this equation in order to get its slope. So that's the rearranged version. And since we want perpendicular, we'll have y minus 0 is equal to. So if this slope is -2, the perpendicular will have the opposite sign. So it'll be positive, and it'll also be a reciprocal. So that's 1/2. So you change the sign and flip the fraction. Then x minus 6 to finish the problem. All right, and the last one down here, perpendicular bisector of the segment that has these endpoints. So first of all, I need to find the slope between these, and then I need to find the midpoint between those. So we'll do slope first. So m is y minus y over x minus x. So that is 14 over 4, which is reduced to 7/2. Now I'm just going to leave it alone because the fraction's fine. To find the midpoint, which is where the bisector goes through, I add the x's and divide by 2, so 2 plus 6 over 2, and I add the y's, 3 plus 17 over 2. So this is 8, so that coordinate is 4, and this one is 10. So there's my point, there's my slope. So y minus 10 is equal to, now since it's perpendicular, my slope is 7/2, so the perpendicular is -2/7. Change the sign and flip the fraction, and then x minus 4. There you go. So these last 4 down here want you to match one of these equations with the answers from up here. So it may benefit us to convert all these into slope-intercept. So this one would be y minus 5 is equal to 2x minus 6, distributing the 2. So y is equal to 2x minus 1. This one is y is equal to 1/2 x minus 3. The 0 disappears. This one, y minus 10 is equal to -2/7 x plus 8/7. So y is equal to -2/7 x, plus, that's actually 77, so 78/7. So let's see here. And I'll rearrange these guys. So this one is -2y is equal to -x plus 6. So y is equal to +1/2 x minus 3. So that was option B up here. Down here, I know this one already without actually solving it because there's a 78, and the only question that has a 78 in it is this third one here. So this one's C. 1/2 x minus 3, that's this one again. So B. And rearranging this one, y is, whoops, off the bottom here. Y is equal to 2x minus 1. That is the first one, A, right here. Okay, so applications. So between this temperature in Celsius and Fahrenheit. So the important thing you have to know here is we're going to call our x, y coordinates are going to be Celsius, Fahrenheit. And there's actually 2 temperatures that you hopefully know, freezing and boiling points for water. So at Celsius, it's 0 degrees Celsius and 32 Fahrenheit. They're equivalent there. Also, 100 Celsius is 212 degrees Fahrenheit. That's the boiling point of water. So the first thing we're going to work out is the slope between those two lines. So y minus y over x is 100 minus, 0. So let's see, 212 minus 32 is 180. 180 over 100 reduces to 9/5. So there we go. So in our equation, converting Celsius temperatures to Fahrenheit and vice versa, so we called our y values are Fahrenheits, so it's going to be Fahrenheit minus 32, the y value there, is equal to 9/5 Celsius minus 0, right there. So if I rearrange this, I get Fahrenheit is equal to 9/5 Celsius plus 32. Now to get the other way, the other equation, I need to solve for c, so that it's going to take 2 steps. I'm going to subtract the 32 across, so f minus 32 is equal to 9/5 c. Now to get rid of a fraction, you multiply by its reciprocal. So c is going to equal 5/9 f minus 32. So those are my two equations. So down here, convert 20 degrees Celsius to Fahrenheit. So I'm going to use this equation. So Fahrenheit equals 9/5 20 plus 32. And the second one, 95 degrees Fahrenheit to Celsius, I'm going to use this equation. Celsius equals 5/9 95 minus 32. And then it all just goes in your calculator. So 9/5 times 20 plus 32. So this is 20 degrees Celsius is 68 degrees Fahrenheit. And then over here, 95 minus 32, and then times 5/9. So over here, 95 degrees Fahrenheit is equal to 35 degrees Celsius. All right, find the unique temperature that is the same in both scales. So what that means is we need to find out where these two temperatures are exactly equal to each other. I forgot how to do this one. With the Celsius and Fahrenheit temperature. You plug one of these equations. No, that'll give you C and C. Oh, you need to graph. Oh, you need to set this equal to that. Will that work? Oh dear. I've literally forgotten how to do this. That's the same in both scales. Oh, whoops. Yeah, I forgot. You just switch the variable. So f is equal to 9/5 f plus 32. And then solve that for f. So if I subtract this across, 1 minus 9/5. Sorry, it took me a while to remember how to do that one. So that's negative 4/5 f is equal to 32. And so it's the same in both scales, meaning that f and c are interchangeable, so I can just switch that c to become an f. And then divide both sides by negative 4/5, so 32 divided by negative 4/5 is negative 40 degrees. There you go. Okay, linear equations simultaneously. Find the unique pair xy that satisfy both these equations. So to do that, we're going to eliminate a variable. So we need to multiply either one or both of the rows by some number in order to get the coefficients to match but have opposite signs. So this one's set up to get rid of the y's first. So I'm going to multiply the top row by 3 to make the y's have a 15, and the bottom rows by 5. So this becomes 9x minus 15y is equal to 39 times 3, 117. This one becomes 10x plus 15y is equal to 35. And then you add down. So there's 19x, the y's go away. 117 plus 35 is 152. And if I divide by 19, I get x is equal to 8. Now that I know x, I can plug it back into one of my equations. So 3 times 8 minus 5y is equal to 39 and solve that equation. So that's 24 minus 5y is equal to 39. Negative 5y is equal to 15. So y is negative 3. So the coordinate is 8 comma negative 3. And that was the end of that section.